This next video is on amides or amides. Again, pronunciation could be different depending on who's teaching you. So, amides. That's what I'm going to call them in this video. Amides are the derivative of the carboxyl group that we found in carboxylic acids, or carbonyl, also from aldehydes. And then joining right next to it, we're going to have a nitrogen atom, which can have up to 2 bonding arms depending on how many are substituted. So if we further condense this, an amide is very similar to a carboxylic acid, just that instead of having an oxygen or an OH here like others, they're all related. We have a nitrogen atom which is bonding to 1 or 2 things, depending on the amount of substitutions. Amides follow the naming style of carboxylic acids when we're doing UPAC, but what we're going to substitute at the end, our suffix is going to be amide. Let's make a very clear and simple example. If I only have one carbon atom bonding to the nitrogen, and here we have hydrogen, and here we have hydrogen as well, so nothing is substituted except for this one, what are we going to get? 1 carbon long. So this would be methane. But we cut off that E, and we substitute for amide, and we get the word methanamide. The rest is as follows with any other organic molecule. We would have to find the longest chain. The longest chain will always begin with the carbon, and then find if we have some substitutions. I'll show you some other examples right now. So I have my basic group, and here I have 4 carbon atoms. I'm going to draw the exact same molecule a few times. But what we're going to add is different so that you understand how the naming works. So here we have 4 identical molecules, except for the fact that now I'm going to add different things. Here I'm going to add a methyl group on the nitrogen. Here I'm going to add a methyl group right on the main chain. And here I'm going to add, let's see, 2 methyl groups, 1 on the chain and 1 on the nitrogen. Let's look at the difference in naming these 4 structures. If I find my longest chain in all of them, I'm going to get 4 carbon atoms. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And here, 1, 2, 3, 4. So, again, the amide group, this is always going to be number 1. This carbon receives number 1. Okay? And then I have to see whatever else I have attached additional to that chain. So in this example, I have a methyl on the chain. In this example, I have a methyl on the nitrogen. And in this example, I have methyl on the chain and on the nitrogen. So let's break it down. They're all derivatives of butane. So I cut off my E, and this is going to turn into butanamide. Butanamide. So all these 4 molecules are butanamide. What is the difference between them? This one, the first one, is just plain butanamide. There's no other substitutions or attachments. Here, however, in this example down here, the methyl group is attached at the N. So this is N, big N, representing nitrogen, methyl, butanamide. Here in this example, the methyl is attached to the main chain. At what number on the main chain? At number 2 out of 4. So then this would be 2-methyl butanamide. And then this last example, we have methyl again at number 2, and we have methyl at N. So by convention, I'm going to draw big N, comma 2, which are the locations of the 2 methyls, di to indicate that we have 2 of them, dimethyl, and the last name is butanamide. So as I said, these are all variations of the same molecule with the additional substituents located in different parts. Remember, we always find the naming style of the alkane, butane, and then we add the suffix, and then we add our substituents before in alphabetical order with the lowest numbers possible.